This class is for class 7 and it is in continuation with the previous class of decimals and fractions. This is fourth part. Today we will be discussing something about approximation of decimals, or it is also known as rounding of decimals. Now what is the meaning of rounding of the decimals? Let's say there is a number 2 and 3. So we divide it into 10 equal parts: 1, 2, 3, 4, 5, 6, 7, 8, and let's say 9. Now 1, 2, 3, 4. Let's take this number. Suppose it is in centimeters. This total line is between, this is 1 centimeter, means you can make out that this point, at this point the value on the line is 2 units, 2 centimeter or whatever, 2 units. Obviously this will be 2.1, 2.2, 2.3, 4, 5, 6, 7, 8, 9 and 10 means 3. What I have done, I have divided 2 and 3 into 10 equal parts. So this, well, let's name it as A, and this point is B. This is P1, P2, P3, P4, P5, P6, P7, P8 and P9. P10 will be your B. So if I say 2.2 centimeter, it means we are talking from point A to point P2. So is it near to, so this 2.2 is near to which number? It will be either near to 2 or near to 3. But we can easily, if we are standing at this point P2, it is easily to move back to point A rather than as compared to point B. Now let's take 2.5. 2.5 is midway. So we always consider that it is easy to reach ahead or above. So this will be considered as near to 3. Suppose I take 2.7. So this is considered to be near to 3. Let's take this. So P7 point or 2.7, it's easy from this point to reach to point B rather than reaching back to A. So what concept has been developed? Rounding off means that we move to that number which is much closer. So any number, let's take a number 9.4825. Now we have to round it. Now this rounding can be done in different ways. First is to any whole number, to 10th place, or 10th place is also known as 1 decimal point because 1 digit after the decimal. Similarly, 100th place is known as 2 decimal points because we will be considering 2 points after the decimal. Or thousandths place, or this is 1000 place is also known as 3 decimal points, and so on. So what is the concept? How do we, or what do we do in that is, now what are the rules? How do we round the decimals? When we are talking about whole numbers, what we need to do? We need to look at the digit after the specified digit. Suppose in this we have to round off 9. So it means that we have to look to the next digit next digit from 9. So next digit from 9 is 4. Now since 4, if the number is specified to the next digit is 5 or more than 5, number next to specified digit, here also it should come digit next to specified. Digit next to specified is greater than or equal to 5. If the digit, suppose we are talking about this 4, if this 4 is greater than equal to 5, then the number converts to the next number. But if the digit is less than 5, the number remains same. And here it is increases. Suppose 9.4825 we are talking, and we are talking about the whole number. So we check the digit 4. Since digit 4 is less than 5, so this number as a whole will be only 9. So it means 9.4825. If this has to be converted to whole number, it will be considered as 9 only. Or very common example, if you have to pay a shopkeeper 9 rupees and 40 paisa, you can pay only rupees 9. Suppose we go to the petrol pump and there the bill is suppose 90 rupees 60 paisa. So he will charge 91 rupees. If the bill is 90 rupees 48 paisa, he will charge us only 90 rupees. Means this is how whole rounding of decimals is done for whole number. Now let's talk about tens place. Now what is the digit at tens place? It is 4. So we will go to the next digit. Next digit is 8. Now 8 is greater than 5. So this number can be written as 9.5. We don't write other numbers. Why? Because we are talking about rounding the given number up to 1 decimal place or up to 10th place. So that is 9.5. Similarly, hundreds place 9.4825. At hundreds place it is 8. So we will concentrate on the next digit, that is 2. And we know that 2 is less than 5. So this number can be written as 9.48. Next is at thousands place. Now in thousands place I'll say 9.4825. What is there at thousands place? 2. It means we need to concentrate on 5. Now 5 is equal to 5. So obviously this number 2 will increase to the next number. So it means this can be written as 9.483. Suppose I increase one more number. That's it. So this is, I hope this you must have understood. What will be the value of 9.25? That will be up to 1 decimal place or up to 10th place, 1 decimal. So that will be 9.3, because we have to convert it to 1 decimal place. So 2, and we will concentrate on 5. So 5 is equal to 5. So this 9.2 will convert as 9.3. Similarly, let's take 11.9463. Now 11, if you talk about whole number, that will be 11.9. We will concentrate on next number after the decimal. This is 9 and this is more than 5. So it will become as 12. Let's talk about 1 decimal place. So 1 decimal place means just 1 digit after the decimal. So the next digit is 4, which is less than 5. So this will remain as 11.9. This is for whole number. This is for 1 decimal place. Then it is 11. Then we are talking about 2 decimal places. So 2 decimal places we will see 4. Means we have to convert up to 4, and we will see the next number, that is 6. 6 is greater than 5, so we can say 11.95. This 4 will increase to one more number. This is up to 2 decimal places. Now let's talk about 11 point up to 3 decimal. We are talking about 3 decimal places. In 3 decimal places, 1, 2, 3. So we will look at the fourth value or fourth digit. Fourth digit is 3. It is less than 5. So this number will become 11.946. Means nothing will be changed because 3 is there. If here it would have been, let's say 5 or 6 or 7, let's say 7. So since 7 is more than 5, this 6 would have been changed into 11.947. If here it would have been 7, then if I have to change the decimal around the decimal up to 3 decimal places, then this 6 would have increased one more point. So I think that this is clear by now. Now we move on to the next topic. Before that, there is an exercise 2D, and there is only to convert the decimals, rounding of the decimals at various places as whole number, as for 1 decimal, 2 decimal, 3 decimals. So we are not solving this exercise. You can do it in your practice notebook. We move on to the next topic, that is about terminating and non-terminating decimals. Next topic is terminating and non-terminating decimals. So what are these decimals? Suppose you have a number, right? Number means a fraction. Let's take a fraction 5 upon 8. If you divide 5 by 8, you will get a decimal number, or in general we can say any fraction when divided, when the numerator is divided by the denominator, then we get a decimal. Suppose I say 10 upon 2. So 10 upon 2 means 5.0. So this is also a decimal. Let's talk about 5 by 8. Let's see over here. 5 when divided by 8, 8 is greater, 5 is less. So we put a decimal point first and then increases you. Now 8 6 is 48. 2. Now again put a 0. 2 8 2 is a 16. Then 4 and 0, 5 is 40. It means 5 upon 8 can be written as 0.625. Let's take one more example, 1 upon 3, or let's say 10 upon 3. So when you divide 10 by 3, you will get 3 3 is a 9, 1 left, put a decimal, increase 1 0, 3 3 is a 9, again 1 0, 3 3 is a 9, 3 3 is a 9, and so on. So what will happen? In this case, you can see the decimal that is coming is 3 3 3 and so on continuously. So terminating decimal means in which the division process ends. You can see in the previous one, the remainder is 0 over here, or the division process has stopped in the first one. In the second one, it's again the division process ends. But in the third one, you can see when you are dividing 10 by 3, division process is never ending, and always you are getting 1 as remainder. You multiply by 3, again 1 0, again 9, again 10, again 9, and so on. Means in this non-terminating, you can see the decimal that we are getting is not stopped. It means it is known as non-terminating. This is non-terminating, and in which the division process ends, that is known as terminating. Terminating what? Terminating decimal, since it is in the form of decimal. So what is a terminating decimal? In which the division process ends or stops and you have remainder only as 0. But what is a non-terminating decimal? In which division process continues and you never get 0 as remainder. Now how to write means if you are asked to write 10.33333, so till where you can write. So the very basic thing is it is written as 10.3 bar. Bar means this is known as bar. So this bar means that the number 3 is continuously repeating itself in this decimal, and this is simply written as 0.625, or if it is a terminating decimal you can write it as it is. But if it is a non-terminating, suppose I say non-terminating, it has to be written with bar. Suppose I write a number 9.1276 and put a bar on this like this. It means this number when written in expanded form will be 9.12767676 and so on. Means that the bar on the digits explain or tell us that those digits are continuously being repeated in the given decimal. Suppose there is one more way to write. Suppose I say 9.12764 and place a dot on 7 and 4. It means that these three numbers are continuously repeating them. Means this means 9.12764, 764, 764 and so on. Means if you are not, or if in some books bar is not placed, you will find decimals. Suppose there are decimals on 2 digits. It means the whole digits which are coming in between those decimals are repeated. Let's say 9.1276 dot and again one dot. It means 9.12767676 and so on. This is all about, we are talking about non-terminating. These you can see the numbers after the decimal are completely repeating again and again. So these are known as non-terminating decimals, and terminating decimals where the division process ends. So that is very simple. I hope this is clear to you. Now let's see what is there next. Now next topic is changing the decimal to fractions. We have learned how we change fraction to decimals, and when fractions are changed to decimals, they can be written in two forms. They can be terminating or they can be non-terminating. So if fractions can be written in decimal form, it means that decimals can also be written in the fraction form. So let's take a number 0.19. Suppose you have to write it in a fraction form. It's very simple. What are you going to write? Remove this decimal and there are 2 digits, so you will divide it by 100. So it is 19 upon 100, or you say 0.25 can be written as 25 upon 100. What we have done, we have removed the decimal and there are 2 digits after the decimal, so we increase these zeros. Now you have to convert them in the lowest form. 25 ones are 25, 25 fours are 100. So this is the correct value of 0.25. But in this case 0.19, since this was not divisible, so this is the final value. I hope this is clear to you. Now we will talk about how to convert non-terminating decimals into fractions. So what is my basic topic? Conversion of non-terminating. Now we will talk about non-terminating decimals. Now let's take a number 1 upon 3. When you divide 1 by 3, 3 you will put a decimal, then a 0, 3 3s are 9, again 1 0, 3 3s are 9, again 1 0, 3 3s are 9, and so on. It means you know that value of 1 upon 3 is 0.33, or you can say 3 bar. 0.3333, or you can also say 0.3 bar, or you can also say 0.3 dot. Now my question is, we have to convert this non-terminating decimal in the form of fraction, and we will see whether our answer or our final value is equal to 1 upon 3 or not. So let us take as question as 0.3. What are we going to do in this? Let us assume that x, there is a variable known as x, and that has been assigned a value as 0.3. What we did, we took a variable x and that has been equated to 0.3. So 0.3 bar, 0.3, that has been equated to 0.3 bar. 0.3 bar means 0.3333 NP. So if I multiply by 10 both the sides, what I will get? 10 times of x is equal to 0.3 and 3 bar, because this was 0.333 and so on. So if we multiply by x, this will become 10x, and in this place, in this, what will happen? The decimal will shift 1 points towards right. So this will be 0.333 or something like that. It will be 3.333 bar, like this. What will happen? This will multiply to x, 10x, and when this is multiplied by 10, this decimal shifts to one place towards right. So now it will become 3.33, I am writing 3.33 and so on. It will become like this. So now if I subtract x from 10x, let us say this is equation number 1 and let us say this is equation number 2. If, or we can say subtracting equation 1 by 2. How are we going to subtract? This is 10x is equal to 3.3 bar, and this is only x is equal to 0.3 bar. When you subtract all the 3's later on, 3, 3, 3, 3 and 3, 3, 3, 3, they will all subtract and the final value will be 0. Means 3 bar and 3 bar will be subtracted and you will get 0 over here after the decimal. And 3 minus 0 is 3. 10 minus 1 is 10x minus 1x is 9x, 3.0. So now you got the value as 9x is equal to 3. So x will be 3 upon 9. You reduce it, 3 ones are 3, 3 threes are 9. Now you can see this value and this value. Both of them are same. It means this is a way how to write non-terminating decimals as a fraction. I will be taking one more example. I am taking writing one more example. That is, let's take a number that is from your exercise. Question is from your exercise 2E. Exercise 2E, and I am taking question number 2 second part. Now what it is? 7.145 and bar on all the 3 digits 145. First of all, what we will do? We will assume let x is equal to 7.145 bar. It means that after the decimal 145, 145, 145, like this, the numbers 1, 4 and 5 are repeating themselves after 3 days. 1 is repeating after 2 digits 4 and 5, 4 is repeating after 2 digits 5 and 1, Again 5 is repeating after 2 digits 1 and 4. So you can see these are repeating themselves. So what we'll do, what we have to do, we have to shift this decimal to this place. This place means 3 digits. So what we'll do, if we multiply by 10, I'm writing it here, if you multiply this number by 10, it will be 71.45 and 145 bar. It will be like this. If I multiply by 100, it will be 714.5 and 145 bar. If I multiply by 1000, it will be 7145.145 bar. It means, and what is our basic requirement? I want to delete all the numbers that are present after the decimal. So I will consider this one a better choice. Means if I multiply both the sides by 1000, this will become 1000x and the right hand side will become 7145.145 bar. Now let us name it as equation number 1. This is equation number 2. So subtracting equation 2 by 1, we get, what do we get? So subtracting equation 1 from 2, we get 1000x is equal to 7145.145 bar and x is equal to 7.145 bar. When you subtract, it means all the numbers after the decimal will cancel it themselves. 5 minus 5 0, 4 minus 4 0, 1 minus 1 0. My main objective is to get a 0 after the decimal point, and that is what we are doing. We tried by 10, but this will not work. We tried by 100, this is not working. But when we tried by 1000, we see that after the decimal again those numbers are repeating, 0.145 bar, 0.145 bar. That is why we choose this one. Now when you subtract 8, 3, 1, 7, 1000x minus x is 999x. It means you can say that x is equal to 7138 upon 999. And you can see that these are in their lowest form. This cannot be cancelled or they don't have a common factor. But you can do, you can convert it into a vulgar fraction by dividing. I am leaving it for you. Now it means x can be written as, or 7.145 bar can be written as 7138 upon 999, or later on whatever is the value. So we have done this. Now we move on to the exercise. Let's see what is there in the exercise. In the first one, question number, I'm rubbing it out. Now we will talk about exercise, and in this exercise, exercise 2E, in the first question is about changing the fractions into decimals. Write each of the fraction as mixed number or as a decimal. So in this I am doing first question, I am doing let's say third part. Now you have to convert fraction as a decimal, and third one is 4 upon 5. You have to convert it in a decimal. Now there are two ways. Either you divide 4 by 5. So put a decimal, then 0, and 8 is 40. So it is 0.8. Or what you can do, you can also convert the denominator in the powers of 10. Suppose the very smallest power of 10 will be 10. So if I make it in the form of a number with denominator 10, I have to multiply this 5 by 2. If 5 is multiplied by 2, then it is obvious that the numerator also has to be multiplied by 2. So it becomes 8 upon 10, and we know that 8 upon 10 can be written as 0.8. So both the ways are correct, and you can do whichever way you feel like is easy for you. Let's take one more part. Fourth part is 3 whole 3 upon 4. So what you need to do? First you need to convert it into a proper fraction. 4 3s are 12 and 3 15. It becomes 15 upon 4. Now if you convert it into the lowest powers of 10, that will be 100. If it is 100, it means it has to be multiplied by 25 in the denominator as well as 25 in the numerator. So in the denominator it will become 100 and 375. 15 into 25 will be 375. Now this can be written as 3.75. This is one method, or you can do divide 15 by 4 and whatever you get, 4 3s is 12, 3 is left, put a decimal, increase 1 0, 4s are 28, 2, increase 1 0, 5s are 20, finish. It 4 7s is 28. So it means this is also the same value and this is also the same value. There are always two methods to convert a given fraction into a decimal, either by dividing or simply changing the denominator in the powers of 10. Now let's take question number 2. That is, we have already discussed the second part. We will be doing some other part. Let's say fourth part. Question number 2, fourth part. And the question is 0.903, and I think the bar is on 0 and 3. It means, first of all, what are we going to do? Let us assume that x is equal to this, and it means that this number is 0.9030303 and so on. We have to write this in the form of a fraction. So first of all, assume that x is equal to this. Now if I increase 1 0, it will be 9.0303. So it means this number we are trying to convert it into 9.03 bar. So this we are multiplying both sides by 10. It becomes 10x is equal to 9.03 bar. Now what we have done in this, we have multiplied this by 10, so we got 10x. We have multiplied 0.9030303 by 10, so we got 9.030303. Now again, if I subtract these two, I am sure that 0.903 and 9.03, we will not get 0 at this place. It means we have to do something else. If I subtract 0.903 bar from 9.03, I am sure that because 3 minus 0 will be 3 and 10 minus 9 will be 1, here we will get something or the other, but my main concern is I want 0 after the decimal. So what we need to do? We need to work on this step. What if I multiply this 10x by 10 and one more 10, means by 100, or if I multiply this by 1000, suppose I multiply this by 1000, it will be 1000x is equal to 903.03 bar. We have converted both the numbers in the form of bar after the decimal. In this also you can make out 9.03 bar. Here also 903.03 bar. Let us name it as equation number 1. equation number 2, equation number 3. So now which two equations we are going to work on? Second and third. So it means subtracting equation 3, equation 2 from 3. So 1000x is equal to 903.03 bar, and then it is 10x is equal to 9.03 bar. We have already discussed how to write the decimals in the vertical form. Decimal should come below decimal. That is why I have written in this way. If you write it as 903.03 bar and you write 9.03 bar, that is wrong. Always remember, whenever we are adding or subtracting decimals, we need to write decimal below the decimal. Now when we subtract them, 1000 minus 10 is 990x. Now in this 3 minus 3, 0, 0 minus 0, 0 means nothing is left after the decimal. Now 9 and 4 is 13. This is 9 and it is 8. So x comes out to be 894 upon 990. Now we have to reduce it in the lowest form. So we can divide it by 2. 2 4s are 8, 2 4s are 8, 2 7s are 14, and 2 4s are 8, 2 9s are 18, and 2 5s are 10. This is the final value. So that is the final value. So we have, I hope you have understood the concept of how to convert non-terminating decimals in the form of fraction. So that is all for today. I hope this much have been clear to you. Then in the next class, I will be doing few more questions of exercise 2e, and that will be the last part of this chapter, decimals and fractions. Now one more thing, if you are facing problems where to write, how to write the questions, so I have already explained. You will start from 2b, exercise 2b, and you will follow the instructions given for exercise 2b, and from 2c onwards, whatever questions we have done in the class, in the virtual class, you will note down in your notebooks, and the questions which are left will be done in practice notebook, and this will be followed for all the chapters from now onwards till anything new comes up. Right? So please like, subscribe and share. Thank you. Have a nice day.